as x increases from 10 to 11. So I think that 2.5 represents an approximation for the increase in y values in the blue curve. I think that 2.5 represents the increase in the y values in the blue curve as x ranges from 10 to 11. I think this represents an approximate increase of $2,500 in total revenue over that 11th year.
Is that just an approximate way of just taking the integral?
No, I think the integral will be completely different. The integral geometrically represents the area needs its curve, whatever integral means. Or Nabil, the integral would be so much more meaningful if this were a rate of change function, which is not. It's not a derivative function that I graphed in blue. It's an actual function. And so the integral, its only interpretation here would be the area beneath the curve.
Okay.
Is this worksheet online?
No, but I can put it on in the classes.
Thank you.
You're welcome. Everybody okay with this? Yes.
Or how did you get 2,500 from 2.5?
Well, if the y values are represented in terms of dollars, or shall I say thousands of dollars,
thousands.
then I think t prime of 10 should represent 2.5 thousands of dollars per year, which is $2,005 for that 1 year.
I didn't read that question. Okay.
So I guess we gave it a meaningful interpretation of that value.
But it is only approximate, right?
Yes, because when you look at my graph, I think when t is equal or x is equal to 11, the y value and the tangent line and the blue curve differ.
Is there a way of subtracting that little sliver to find the exact? Is that beyond us?
No, it's not beyond you. I just think what would be better is to value the blue function at t equals 11, and then look at the difference between that and the tangent line's evaluation at t equals 11. And that would answer the question.
And that'd be a lot easier way of answering the question.
You know, in practice, it might be a lot more difficult. That's why I think this is easier. I think just getting an approximation is really nice. I like this approximation. Can you guys give me t of 10? I think t of 10 is, actually, I don't know what it is. I have no clue.
50,000.
Is it 50,000? Is it 50,000?
I think it's 5,000.
No, I think it's 5,000. All over
200?
200. In other words, 25. Who the heck cares? What does that mean?
Because that's the,
$25,000.
that's how much.
What about
money
$25,000?
At the 10th year, they made exactly $25,000.
You mean over 1 year?
That's the total amount
No,
they
the
made
total
up to that
amount.
point.
Ah, so
Over
at
10
t
years.
equals 10 years, after 10 years of this record being on the market, I have earned a total of $25,000. That's a total amount of money earned from marketing this particular thing.
The derivative determines the amount of money earned each year, right?
Or how about saying it a little bit differently? The derivative function gives you the increase in income.
Oh, so it is
Per
a
year.
rate, okay.
It's an increase, which is not the total amount. But that's what t is, the total amount. You guys, I'm too tired. And we're out of time. If I added this number, what would it be? No, I misspoke. If I added this quantity, what would it be?
Would be the actual amount they made.
Beautifully put. I think that would be the increase in y values in the blue curve from here to here. I think this quantity right here will be t valued 11 minus t valued 10. That would be the actual increase in total revenue over that 11th year,
Not the approximation. But
not the approximation.
So it'd just be number 2, but exact.
Very nice. You can't see it, but that was Nabil, you just answered that question. What's the relationship between the answers in part 2 and part 4? Well, I think the answer in part 2 merely approximates the value in part 4.
In this case, would they end up being the same value?
No, they don't. In my picture, you can clearly see they're not the same values. What about my last question?
Is that infinity?
Yes, it is.
Isn't that the total amount you've made over the course of time?
Don't go there yet. Answer the first part of the question. I'm sorry, sir, you're right. But answer the first part of the question.
50.
Where'd you get 50?
Because the x squareds cancel out and it says 50.
If you insist. Or take the limit and multiply top and bottom by 1 over x squared, you get the same answer. It's 50. Or you really mean $50,000 is what? What does $50,000 represent?
Total revenue.
But I can't keep this in the market for infinity years.
Well, it's totally.
Well, they are the derivatives, I suppose they could. They're mathematically inclined. My point is, that's nice. It's a projection of how much income I can possibly have over time for this particular record. As time increases that down, the total revenue will never increase beyond $50,000. Do you guys see my point? I'm just trying to shake you guys up. I want to. I spent too much time on theory. I want to start coming back now to applications, just like the author of your text. And so everything I've done in the past few examples is just dealing with applications of derivative, instantaneous rate of change. Can I have you guys just practice? Okay. Getting some practice.
Is there going to be a take-home quiz?
Oh, if you like, yes, I have not written it. You're gonna, sorry, you guys, you're going to have to wait till Friday.
Okay.
Can you do that?
Then we'll only have.
I don't know.
Give us a high.
The waiting will just be too long.
Oh, I see.
That's far too little time. To feel comfortable.
What's wrong with you? Easy access, that way I don't have to refer to the video each time. That's a banana.
And you guys, I'll put this online real quick, okay? Just give me just a couple minutes and we'll get there. Because somebody asked. So